I suppose that the colleagues are connected now. And for now, dear friends, we are moving to the follow-up question. The connection is good now. And now we are giving the floor to the experts, and now we have those who are ready with their questions. So let's give the floor to Carlo Leandro.
Okay, so...
Can you hear us well?
Hello, can you hear me?
Yes, we can hear you.
Yeah, we can hear you.
So first, congratulations on the presentation. Well, I think you're still in the phase that you're still studying about geopolymers, and I believe you're still gonna perform additional testing. But based on what you've studied, are there possible components of metallurgical waste that you are going to use in these geopolymers that might interact with steel or with reinforcing steel in construction? So you're going to use nickel slag and red mud, and I believe aluminum and silicate slag. So are there possible interactions with steel that might accelerate corrosion in the when you use geopolymers as a construction material?
Should I answer now?
Yeah, that's
okay.
The question.
Okay, really thank you for the really good question. So basically, from what we have tested or for what we have researched at least, for example, nickel slag in Sulawesi, red mud in Borneo, and aluminum and silica slag in Banten, not any of them are reacting, especially to steel. For example, a lot of steels that we can talk about is around the eutectic or eutectoid point, for example, right, which is around 0.022 up to 2.1, and up to this point, from what we've seen, especially for a concrete that has a steel beam inside of it, there has not been a big changes. However, there are some, well, not really a problems, but there is some normal concrete that you can see as alkali silica reaction, in which like the reaction creates a concrete cancer, but does not just occur in geopolymer, but also occurs in concrete in general, especially in OPC. But that's the thing, rather than using raw materials, that's why we're applicating the waste materials for that the applications can be better, at least it is more cost efficient. But as of reacting towards a steel beam or iron whatsoever, there has not been any significant reactions other than the alkali silica reactions or the ASR. Thank you.
Thank you very much.
Спасибо. Уважаемые китайские коллеги.
May I have a question? Colleague from Wenzhou University.
谢谢你刚才的讲演，应该说讲得非常好。
Thank you a lot for your presentation. That was really good.
这个土工集合物的想法也是，据我了解，也是我们很多人的一个想法。
As far as I understand.
那么我想问你一个问题，就是你对
Many of us share that this technology of geopolymeric concrete is really good.
大概有多大的期望值？就是它的强度，你期望它能够达到多少？
What's your opinion? Considering the investments that can be attracted in this area of production of the geopolymer concrete.
Okay, allow me to answer first, and my friend will continue after this as well. So basically for geopolymer investment, one of the biggest costs that will be taken is the solvent, right? Because as we can see, instead of using a really long chain of production that is OPC are using, the biggest problem with it is also the solvent. For example, as you can see on the economical considerations that we have, it's really cheap in the long run. However, the solvent can really be a problem. However, as we insist in our presentations, we are more concerned regarding the sustainability of this project rather than the initial investment, because if we're talking about, well, the initial investment, both can be really big, but however, as in the sustainability with like the cost and etc., geopolymer will be cheaper rather than the OPC. That's my answer to your question. Thank you.
不好意思，就是这个刚才可能我说的比较快，我的问题不是指经济性，我的问题是想问你这个土工聚合物的强度 ，strength, not cost. 就你期望这个混凝土土工聚合的混凝土能够达到多大的强度？
What should be the solidity of this concrete? How solid should it be? How solid, how strong should it be?
The strength of this kind of concrete.
So how strong should it be? What's the strength of this geopolymer concrete?
Yeah.
So basically, if we're talking about solidity, we would like to revert more to the strength of the geopolymer. For example, when we're talking about the strength and compactability, we are really refer to the hardness for what we have learned. We may have not learned enough, but I will try to answer your question. For example, for the strength, if we're talking about the geopolymer itself, one of the research that we have done, or not what we have done, however, what we have seen on the paper on the ResearchGate, a lot of, the geopolymer can range around from 50 to 70 megapascal for one brick of geopolymer from the, alumina and silica slag, but that is like the normal geopolymer that is usually been there. However, there for future project, for example, it may be better, but that's what we get from your questions regarding the strength and the solidity of the geopolymer. However, again, as we're talking about hardness, it does still have the brittlity of ceramic. So even though it's strong, it's still not ductile. So as of solid, it's still solid, it's strong, but it's not tough. Thank you.
Спасибо. Вэньчжоу, есть ли еще вопрос?
Thank you. Wenzhou, any other questions from your side, or are you done with the questions?
请问你们形成这个土工聚合物会不会有二次污染？就是说，这个废弃物本身的有害元素，你们有没有方案里面有没有把它先去除完了以后才形成聚合物？就是说，这个土工聚合物里面这个不是，就是说这个废弃物里面的有害元素怎么样去除？会不会造成二次污染
？This recycled geopolymer concrete has some bad substitutes, so can it be environmentally polluted?
Okay, allow me to answer once again. So basically, again, as it is have been using the waste material, but the biggest problem, regarding the sustainability of geopolymer is that right after the curing, right after the compaction and after the curing, it cannot be reused again. However, the small blocks that it can be reused as just like a small box, not like a solute in a solvent. So as we were talking about sustainability, future sustainability, sure, it can practically be used again as it can be destroyed and just put in a cement, for example. However, it will not be able to reuse again, of course, due to the like the recycled concrete sludge and the fly ash is not really reusable as it is already a waste already. So right after the alkali solutions, right after the curing temperature, right after they became the final product, and then if something were to happen, it cannot be reused again. However, as it uses a lot of, well, mostly waste materials, the sustainability does not have to be really thought further due to the fact that we don't have to rely on raw materials such as from the OPC. I hope that answers your question.
I want to add that besides that, it has a very low rate of greenhouse gas emission when compared to ordinary Portland cement. That is all.
Спасибо.
Question.
Thank you.
Был вопрос от эксперта Мамаду.
Dear colleagues, there was a question from Mamadou. So, are you still willing to ask this question?
Вы нас слышите?
Or Vladimir Bajinov. Can you hear us?
Hello? Can you hear me?
Yes, we can hear you very clear.
Yeah,
Okay. First one is a very good presentation, very interesting topic. The question for me, I have like, I know Indonesia have some, I think, alumina plants which produce residue like red mud residue. I'm not sure like if you guys consider that type of residue in your study. I know you talk about aluminum silicate, but I'm not sure it's from red mud residue or you're taking it from the nature.
Allow me to answer your question. Thanks a lot for the clarity of the question. I would like to answer. So basically, we did talk about the red mud, and yes, we meant regarding the residue of the plant. Really sorry on our part for not to clarify it. Yes, but it was from red mud of the residue from the plant in Borneo, especially that are used on the geopolymer concrete application. Thanks a lot for the question. I hope that answered your questions.
Yes, and one another concern that I have seen in the past on paper, people have concerned the heavy metals that we have in the residue. Do you guys treat it out, or they will be contained in your final product?
Again, thanks a lot for the question. Regarding tungsten in Indonesia, there has not really been a tungsten production in a big manufacturer and a big industry as if on the silica or aluminum. Though it can be treated such as geopolymer, but it is not really a big, well, you can say not really a big focus for Indonesia right now due to the fact that the tungsten plant has not been really used, especially due to the fact Indonesia from 2016 from President Joko Widodo are focusing more on the steel production, nickel production, as we have found more availability of those rather than tungsten itself. So basically, yes, we can treat as such, but that is not the main focus of the Indonesian researcher now. So thanks a lot for the question.
No problem. Thank you.
No problem.
Спасибо. Увы, вынуждены закончить.
Thanks. We're really sure, but we should end up here with the follow-up question sessions, and we have some other teams to work further. So, dear experts, you would have an opportunity to ask the question next time. So, the team of Indonesia, you did really great. So, this is the first time of your participation in the championship, but that was quite positive, and we can feel the atmosphere of your conference. We can feel your mood. Good luck to you.
Thanks a lot.
You're really great guys. Just we can say hello to you from President. So just have really good solutions. Good luck to you in the final.
Thanks a lot.
So good luck, and we hope we will see you.